Your biggest client's traffic just spiked to 10x normal. Your auto-scaling should handle this, except it's not firing. You pull up the console to manually trigger scaling. The page loads slowly. You click Add Instances, Spinner. 20 seconds pass. Error. Request throttled. Try again. You refresh. Another error. Your monitoring shows CPU hitting 95% across all instances. You need to scale now. You try the API directly. Rate limit exceeded. Every control surface you have is choking. Not because something broke, because everyone is using it simultaneously. The support team is checking dashboards. The DevOps team is trying to deploy a fix. The executives are refreshing metrics. And the cloud provider's API, handling millions of panicked requests from thousands of customers all hitting problems at the same time, is drowning under load. This is control under stress. When you need control most desperately, it works least reliably. Let's talk about how control degrades, why it happens during crises, and what's left when the control surfaces stop responding. Control degradation is when your ability to manage cloud resources becomes progressively less reliable, less responsive, and less capable. Not gone, degraded. Commands take longer. Operations fail intermittently. Visibility decreases. The control surfaces still exist, but they're limping. This happens in two distinct ways that often compound each other. First, there's acute degradation. Control under stress. This happens during incidents, outages, or unexpected load spikes. The systems that normally respond instantly start lagging. APIs that normally return in milliseconds now time out. Consoles that load immediately now hang for minutes. Everything gets slower and flakier exactly when you're under time pressure to fix critical problems. Second, there's chronic degradation, control drift. This happens gradually, over months. Permissions accumulate. Nobody remembers what certain service accounts do. Automation that worked perfectly 6 months ago now fails mysteriously. The infrastructure as code doesn't match actual deployed resources. Documentation is outdated. Control isn't broken, but it's messy, unreliable, and increasingly unpredictable. Both types erode your operational capability, but in different time frames. Stress degradation happens in minutes during a crisis. Drift degradation happens slowly until you discover it, usually during a crisis when you really can't afford the surprise. Let's focus on acute degradation first. What happens to control when systems are already struggling? API throttling hits hardest during incidents. Cloud providers implement rate limits to protect their control planes from overload. Under normal conditions, you never hit these limits. During a major outage affecting thousands of customers, everyone is frantically calling APIs, refreshing dashboards, deploying fixes. The control plane gets hammered. Rate limits engage. Now your legitimate emergency operations are being throttled alongside everyone else's panic. Consoles become unusable under load. Web interfaces that normally render instantly start timing out. JavaScript-heavy dashboards that load dozens of API calls choke when those APIs are slow or failing. You're trying to view metrics to understand what's broken, but the metrics dashboard itself won't load because it's making the same API calls that are being throttled. Database control planes exhibit back pressure. You need to scale your database urgently, but the control plane that handles scaling operations is itself a database that's now under heavy load from thousands of simultaneous scaling requests across all customers. Your operation gets queued. You wait. The database you're trying to scale keeps degrading while you wait for permission to help it. Authentication systems become bottlenecks. During an incident, your entire team needs access. Everyone tries to log in simultaneously. The identity provider that handles authentication is itself experiencing high load. MFA requests time out. Session tokens fail to generate. Half your team can't even get logged in to help respond. Monitoring and observability degrade when you need them most. The systems collecting metrics are under the same stress as everything else. Metric ingestion falls behind. Dashboards show stale data. Alerts fire late or not at all. You're making decisions based on information that's minutes old, which in a fast-moving incident might as well be ancient history. The cruel irony, stress degradation, is pro-cyclical. Problems cause stress. Stress causes control degradation. Degraded control makes problems harder to fix, which increases stress. The spiral accelerates until something breaks completely, or external factors relieve the pressure. Now let's talk about chronic degradation, the slow erosion that happens when nobody's watching. Permissions sprawl destroys clarity about who can do what. 6 months ago, you had 5 admins. Now you have 17, because people kept needing temporary elevated access that never got revoked. Service accounts multiply because each team created their own rather than using shared ones. You're not sure anymore who has access to production. The permissions exist, but understanding them, that's degraded. Automation decay happens silently. Scripts that worked perfectly when written now fail because dependencies updated, APIs changed, or assumptions about the environment no longer hold. Nobody noticed because the automation was only used occasionally. Now, during an incident when you desperately need that automated failover script, you discover it hasn't worked in 3 months. The control existed on paper, it's gone in practice. Configuration drift means your infrastructure as code doesn't match reality. Engineers made manual changes during incidents. They meant to update the Terraform afterward. They didn't. Now you have resources that exist but aren't in version control, and resources in version control that don't match production. You're not sure which configuration is authoritative anymore. Control of infrastructure state has drifted into uncertainty. Documentation rot leaves you guessing during emergencies. The runbook for handling database failover is 18 months old. Half the steps reference systems that no longer exist. The person who wrote it left the company. You're improvising based on incomplete information because the documented control procedures have drifted away from operational reality. Team knowledge attrition compounds drift. The engineer who understood the networking setup left. The person who set up the monitoring configuration moved teams. The architect who designed the disaster recovery strategy retired. Their knowledge left with them, but the systems they built remain, increasingly mysterious and fragile as tribal knowledge degrades. Drift is insidious because it's gradual. Each individual change seems reasonable. Cumulatively, they create chaos. And you don't discover the full extent of drift until you're stressed and trying to execute control that theoretically exists but practically doesn't work anymore. So how do you maintain control capability when everything is degrading? For stress degradation, build control redundancy. If the web console is your only control surface and it's down, you're stuck. Multiple independent control paths, console, CLI, API, break glass procedures mean when one degrades, you have alternatives. Secondary accounts with lower rate limits that aren't being hammered. Out-of-band access that doesn't depend on the same authentication system as primary access. Implement backoff and retry logic that adapts to degradation. When APIs start throttling, your automation should slow down, not hammer harder. Exponential backoff gives stressed systems room to recover. Circuit breakers stop automated systems from making stress worse. Pre-position critical operations before stress hits. Auto-scaling configurations set up before the traffic spike. Failover procedures tested and ready before the outage. Break glass credentials distributed before the authentication system fails. You can't set these up while control is degraded. You need them ready. For control drift, periodic audits are non-negotiable. Quarterly permission reviews, monthly infrastructure as code drift detection, regular testing of automation and disaster recovery procedures, documentation reviews that verify accuracy. These audits catch drift before it accumulates into operational chaos. Immutable infrastructure reduces configuration drift. If you rebuild instances from code rather than modifying them in place, drift can't accumulate. The code is the truth. Deploy from code, and you're always in a known state. Automated compliance checking detects drift continuously. Tools that compare deployed infrastructure against code and flag differences. Alerts when manual changes happen. Automated correction that reverts unauthorized modifications. Don't wait for audits, catch drift as it happens. And crucially, invest in control observability. Monitor your control surfaces the same way you monitor applications. Track API latency, error rates, rate limit consumption. When control starts degrading, you want to know before it becomes critical. Control degradation is the slow-motion failure that happens both acutely during stress and chronically through drift. Either way, it erodes your ability to manage systems exactly when you need that capability most. Stress makes control unreliable during incidents. Drift makes control uncertain during normal operations. Together, they create situations where you're theoretically in control, but practically powerless. The answer isn't fighting degradation, it's building systems that maintain capability even as individual components degrade. Redundancy, automation that adapts, continuous auditing, and accepting that perfect control is temporary. And remember, control that works perfectly until it doesn't isn't really control. Talk soon.